Number 4 here is calculator inactive. It says consider a differentiable function f having a domain of all positive real numbers, and for which it is known that the derivative is equal to 4 minus x times x to the negative third for x is greater than 0. Find the x coordinate of the critical point of f. So critical point of f, f prime of x equals 0. So it's in factored form. Set each piece equal to 0. So that says x equals 0, but 0 is not a part of our domain, so that's not a consideration. X equals 4 here is in the domain. That's a positive real number. Determine whether the point is a relative maximum or relative minimum or neither for the function f. Justify your answer. So let's start with a number line, but do remember that a number line is not good enough. We're going to have to put this in words for actual true justification. So f prime of 1, if we plug it into the factored form, that's the easiest way to evaluate it. 4 minus 1 is positive. 1 to the negative third is positive. When we plug in 5, 4 minus 5 is negative. 5 to the negative third is positive. Okay, the negative exponent doesn't make it a negative number, it just makes it a really tiny number. So we are positive to the left of 4, we are negative to the right of 4. So we can say in words, since f prime of x is positive, or we could do it symbolically here. We could say since f prime of x is greater than 0 for 0 to 4, and f prime of x is less than 0, aka negative, for 4 to infinity, f of 4, we're talking about the critical point, f of 4 is a relative, what would that be? If the derivative changes from positive to negative, then that means the function changes from increasing to decreasing, so that would be a relative maximum. So you get 1 point for identifying your critical number, you get 1 point for saying it's a maximum, and 1 point for your justification. Part B. Find all intervals on the graph, on which the graph of f is concave down. So concavity leads us to second derivative, so let's start by finding the second derivative. Product rule. First times the derivative of the second plus derivative of the first times the second. We need to know where this is equal to 0, so we need to put it in factored form. Remember, this is that weird factoring. First of all, both of these have a negative in them, so I'm going to pull that out. We need to take out the smallest exponent. So the smallest exponent here is x to the negative 4th. So when we take that out, we're left with the 3 times the 4 minus x, plus we took out that negative, x to the negative third divided by x to the negative 4th. Because remember, when you're taking out GCF, it's really like you're dividing. So negative 3 minus negative 4 is plus 4, so that's x to the first. Let's simplify things a little bit. Inside these parentheses, 12 minus 3x plus x. So we've got negative x to the negative 4th is equal to 0. Again, that's going to give us x equals 0, not in our interval. This piece is going to give us 12 minus 2x is equal to 0, so 12 is equal to 2x, so 6 is equal to x. So that is our critical points. I'll go over here, test it, okay, plug it into the second derivative. When we plug in 1, we're going to get a negative times a positive, so that's negative. When we plug in 7, we're going to get a negative times a negative, which is a positive. So since f double prime of x is less than 0 for 0 to 6, then f of x is concave down for the interval 0 to 6. You get 2 points for your second derivative, so I'm going to put that right there, and you get 1 point for your answer with justification. So concave down with the reasoning that the second derivative is negative. All right, last part. Given that f of 1 equals 2, determine the function f. So we want to know f. We're given a derivative, so we need to anti-differentiate. So f is equal to, there's a couple of different ways that we can do this, but how about we do it similar to the other problem? Since we're given this initial condition, 2 plus the integral from 1 to x of f prime, or you could just anti-differentiate it in general and plug in your initial condition. But let's go with it this way. So the antiderivative of this function, we need to distribute it out. So I'm going to take an extra line right here. I'm going to distribute that x to the negative third, because we can't anti-differentiate this in factored form. So when we distribute it, we get 4x to the negative third minus, when we multiply x times x to the negative third, we add their exponent, so 1 plus negative 3 is negative 2. So antiderivative. Add 1 to our exponent, divide by the new exponent. Whoops, it's a minus. Add 1 to our exponent, divide by the new exponent. That's from 1 to x. Really, technically, I shouldn't have an x there, but I don't know how bent out of shape they get over that. Let's keep going. Let's simplify before we plug stuff in. Let's simplify. So that's negative 2x to the negative 2 plus x to the negative first. So when we plug in our x, we get obviously what is there, minus, let's plug in 1. And I'm just copying down what we've got. Okay, so negative exponents. Don't get bent out of shape over that. Remember, it just moves it to the denominator. Well, we're really lucky here because we're raising 1 to that power, so 1 to any power is 1. So we've got negative 2 plus 1 down here, so that's negative 1, and we're subtracting negative 1, so it's really like we're adding it. So we end up with 3 minus 2x to the negative 2 plus x to the negative 1. If you really want to get rid of those negative exponents, you can, but the rubric has it that way because that's how the original function was, so just leave it. Again, you keep writing, they keep grading. Don't lose the points there. You get 1 point for setting up your integral. You get 1 point for the antiderivative, which would be right here. And you get 1 point for your final answer.